This is Sofia Feltzing. She's an astronomer who wants to understand the Milky Way.
Och där blev det lite ljus i alla fall.
A while ago, we had the idea that the Earth was at the center of the universe, with the sun, stars, and planets all orbiting around us. But over the last century, we began to understand that this is not the case, and that we are actually part of a solar system in a galaxy among billions of others in a seemingly endless universe. But there are still many mysteries about the fundamental elements of this understanding, such as how the Milky Way, our own galaxy, was once created. Sofia is looking to the stars to find the answers.
So stars are like time capsules. In their elemental compositions, they carry information about the conditions in the gas that they formed out of.
Our solar system lies in a corner of the Milky Way galaxy. Our sun is just one of the Milky Way's 200 to 400 billion stars, which are constantly changing. They move, die, and new stars emerge out of the material left over from the dead stars. This is precisely what Sofia is studying. She compares the different ages and compositions of the stars. By doing this, she can calculate the galaxy's structure and hopefully begin to understand how it has changed over time.
And by studying them, we are able to learn about the processes that has formed and shaped the Milky Way galaxy. This is just one other step on understanding our environment in the universe.
Sofia's research is based at Lund University, but the project she runs is an expansive collaboration including astronomers from Uppsala University and astronomers and engineers from all over Europe. Together, they have started mapping the Milky Way's stars and structure.
Nu så ska vi gå och ha gruppmöte med stjärnpopulationsgruppen här i Lund. Vi har ganska många möten faktiskt eftersom vi ofta behöver sitta och pratas vid. Om forskningen vi gör, precis det vi håller på med, eller ibland så pratar vi om artiklar, något som någon annan har gjort.
The fact that astronomers cannot perform experiments on their subjects puts even greater importance on discussions about methods and theories. The groundwork for Sofia's group is partly based upon previous research, but most of it is coming from data collected through observation using telescopes in Chile and the Canary Islands. Every year, Sofia's group submits applications to the observatories in order to get the chance to gain new information 1 to 2 times a year about the stars they want to study.
Kan du inte flytta den? Hur många ska jag ha det? 4. Varje sån här liten röd glasspinne är en illustration av att det finns en optisk fiber där. Men Thomas har hand om att göra de här filerna som talar om för teleskopet exakt var den ska sitta någonstans. Och jag inte vet om det blir bra eller dåligt.
Det blir jättebra.
At the observatory, they use a file from Lund to point to the exact coordinates of the stars to be observed. Optical fibers are then placed on the telescope's focal plane, precisely at the positions of the stars. The light from the star then goes through the optical fiber and into a spectrograph, which brings out the star's own unique spectrum signature by light wavelengths. With this information, the group can determine which elements comprise the makeup of the star. By using this technology, they have discovered that there are 2 different types of stars, and among other things, their oxygen content makes them different. One has a much higher oxygen content than the other. It has also been possible to establish that the stars have different ages. Those with a higher oxygen content are older than those with a lower content. In addition to their different compositions and ages, their patterns of movement differ when they circulate closer to the galaxy's center. The older stars move freely in broader and more dispersed orbits, while the younger ones move slower in a smoother and more narrow path. The researchers call these different paths disks. It's with the disks that scientists are most puzzled. Why do stars have such disparate movement patterns? And more importantly, how can their content differ so greatly? New stars are formed from the dust of dead stars, and it's almost impossible for stars with such different compositions to be formed in the same place. The question is whether this can tell us anything about how our galaxy was formed.
Kan det ha varit så att vi först hade en väldigt tunn disk som hade bildats under normala sätt och sen så smackade in en annan galax i den och så blev den tjock. Och sedan så regnade det in ny gas där man kunde börja bilda en tunn disk då.
That our galaxy was originally two galaxies which collided is just one of many theories that try to explain different stellar compositions and movement patterns. But verifying these theories requires more searching of larger areas to see if things look the same elsewhere.
Jag har ett stort behov av att titta här och ut och in och överallt. På så många ställen som möjligt för att liksom kunna dela upp det hela, bena ut det. Det är som, ja.
So far, astronomers have only been able to study relatively small areas around our own solar system. But in the next 10 to 15 years, things will be completely different for Sophia and her team. In 2013, the satellite Gaia was sent into orbit and will within a few years start to deliver the exact positions and distances of billions of stars and celestial bodies from vast areas of our galaxy. Additionally, parallel to Gaia, another project is underway, Foremost, an effort to develop more advanced spectrographs with the ability to capture up to 2,000 stellar spectra per viewing, compared with today's technology which can only study 100 to 200 objects at a time. Together, these will lead to entirely new possibilities.
So with Gaia combined with Foremost, we'll be able to do very directed things and say, here we want to look very deeply in one direction, or we want to do a panoramic study measuring all types of stars across a larger region, and we will really find things that we hadn't expected, things that you really didn't know were out there.
The data Gaia collects will provide basic information to create a large-scale and detailed database of our galaxy's appearance and movements. Together with Foremost, which analyzes individual stars, astronomers will have unprecedented opportunities to know more about the positions and properties of the stars. Gradually, the pieces of the puzzle will fall into place as the big picture of the Milky Way's history, appearance, and composition emerges more clearly.